So to start, we're going to be looking at the Arkite Operator Guidance System. This is a digital work instruction platform that projects real-time work instructions in front of the operator to help them with any assembly or verification processes that could be impacted by any human error consequences. We have 3 platforms as part of the Arkite option packages. We have Guide, Validate and Vision. So the first platform that we'll be looking at is the Arkite Guide. What this consists of is the Arkite software and a projector, which helps to digitalize work instructions and project them directly in front of the operator, which the operator will have to manually push forward each of the step sequences in order to move forward on their assembly and verification. And the next platform version is the Validate. What this consists of is the software, the projector, and incorporating with the 3D sensor time of flight. What's that then doing is validating what the operator is doing. It's seeing exactly what the operator is doing within the space and then confirming that the correct action has taken place within that step sequence. Therefore, it's preventing the operator from being able to push ahead of the program because everything will be watched directly in front, and then we'll send the information back to the system and project whether or not the operator has made the correct action or an incorrect action. So you have a full quality process or product. And the latest release of the Arkite Operator Guidance System is now incorporating with Vision, which is what we'll be covering today's topic of the webinar. This includes the Arkite infrared vision camera, as well as all the additional hardware presented in the Guide and the Validate, with the 3D sensor and the projector and the software. Now, what the Vision element is doing is actually then verifying that the physical part itself is in fact the correct part in that stage sequence, helping you to confirm that you have a full quality product from start to finish within the process. And now I'm going to show you a demonstration of the Arkite Operator Guidance System in action. This will incorporate different elements of the Guide, Validate and the Vision, but we'll be focusing on the technical aspects of the Vision and the software in a little bit later. But first, I'll take you over to the demonstration bench here. So now you can see here from the demonstration bench, we've got a missing wrench that I need to move into position. That will then verify and allow me to move forward. We've then got the barcode scanner, which is signaling me to pick which product variant. We've got 3 options: the red tube, the blue tube or the black tube. For this demonstration, I'm going to choose the blue tube. I will put the barcode scanner back, and then once I've confirmed that, it will allow me to move on. We've then got a virtual button in position here. It's then confirming, I need to confirm to the system that the assembly block is in fact in position. And then it's giving me the next guidance of highlighting to pick the housing. I'm going to purposely put this into the wrong position onto the fixture base, and what you will see is that the vision camera is checking the orientation. It's roughly 180 degrees out of specification. Once I've put it into position, it'll allow me to move on to the next build process. Highlighted with information there and guiding me to where I need to pick and place things from. Picking from the screw, the vision camera is looking to see that the presence of the screw is there or not, and highlighting me that I need to position that in. Once I have in fact put the screw in its location, the system will sense, and then I'm allowed to move forward using the Bosch Nexo Smart Tool. Take the tool. I'm not allowed to use the Smart Tool unless I'm in the correct stage or in fact in the correct position for the screw to be used in. I will use the screw, stop halfway. I've not reached the correct torque value yet. Once I have, you can see it's allowed me to move forward and position the tool back onto the holder. Once to detect the presence of that, it's now giving me the information to pick the blue tube. If I was to in fact pick the wrong colour tube, the system is highlighted with the giving me a red signal that the incorrect tube has been chosen. Once I pick the correct tube, Picking the connector, I will purposely miss the tube out. The system has detected that and it's given me a rework option. I will then look to rework, pick a new tube, put the tube in position. Once the system has checked that, I'm allowed to move on using the wrench, tighten that up, put the tool back, pick the double-sided connector. I've got some additional information here helping me as an operator with a GIF and directions. I will then put the connector in position. Once it's seen that, I'll take the wrench, same again, tighten up, place the wrench back, and I've completed the application. I'm then given some additional information on the assembly report as to who I was, what training level, the tube variant, how long it took me to build it, and how many errors I made within the build process. With a virtual button, choose to move on, and then it will start the process again where I can take the barcode scanner and pick which variant I'd like to build. So Arkite's USP is its ability to be able to integrate with different connectivities and different ecosystems. What you'll see from the slide here is that it links with different software capabilities of ERP or MES systems, different protocols whilst linking with Siemens, for instance, open protocol which would be used for smart tooling. We also can connect with different barcode scanners, FRID, label printers, additional projectors for expanding the projection view range, additional PLCs, and maybe potentially different vision systems with different capability requirements. And if you remember from the demonstration, we linked it with a barcode scanner, which then allowed me to choose the different product variants from the blue tube. Pick the barcode scanner back in position, and then if I go back to the smart tool element where I'm picking the screw, put the screw in location, vision camera checking, taking the Bosch Nexo Smart Tool, the tool will not be able to be used until I'm in the correct build process or if I'm in fact in the correct location. So as you can see, it's changed colour. I will stop. Doesn't allow me to move on. We've got information about what the different torque levels are, and then it allows me to put back. So the good element of that is that what you can have is potentially different torque values for different screws in different orientations, which means that then you've got a full quality product utilising the different functionalities that the Bosch Nexo can offer, or any additional versions of smart tooling for whatever your company process is. And now I'm going to give you a quick overview of the Arkite software. Here you'll see on the screen, using the Arkite software, it's a really user-friendly software. It's just got 3 tabs. You've got detections, processes, and connectivity. And each of these tabs make up building the Arkite program. So here we have detections. That's everything that is what the 3D time of light sensor is seeing. As you can see, my hand's going up and down. It's using infrared and depth sensor technology. This then guides the operator and watches where everything's happening in the locations that you create the system to see. So here we have containers, we have an activity area, we have tools, then we have processes. This is all of the step sequences that you would create as part of the assembly processes. Each of these being the step-by-steps of the detections, picking, placing activities. And then connectivities here is everything from the projector to the screen, to the 3D sensors, the vision sensors, and any other communication that you would need to connect it to, being the barcode scanner and the smart tool for this demonstration. We're going to have a little look here at the checking element of the vision camera. So if you see here, we've got checking for the presence of a screw. Again, it's a really easy teaching detection for whether or not the part is present. So if you see here, we are checking the presence or not of the screw, and we have a percentage margin of whether or not the expected result is correct or incorrect to the version that you have taught. And now we're going to teach the system to recognize part orientation. I'm going to take the oil filter and we're going to show the system the wrong results. Press wrong here, it will create an image. I will then change the orientation 180 degrees to the expected result. We want to show error visualizations so that when it's the wrong result in the process, it will highlight that. Very simply click teach. And then what they will do is create an image file to look at what is the percentage range of the wrong or expected result, which is how it determines from the pixels of how much of an accuracy that image looks like. The program that was inputted, if I pick the oil filter, place it in position, it now says check oil filter is in the correct orientation. Once I turn it around, it will then allow me to follow on to the next stage process of pick cap container. And now what I'm going to show you is a quality check looking at the presence of an object. For this instance, we will look at the screw. So I will add a new detection quality check. Call this screw QC. Press OK. Now for this, what we'll want to do is change the detection box range to be much smaller, as this will be looking within about a range roughly of 3 millimeters, dependent on the orientation of the sensor above and how far away it is. So first we'll teach the wrong results. Obviously that's without the screw. We will insert the presence of the screw, and then we'll put the expected result is with the screw. Teach. And as you can see here, we've got roughly nearly a 98% of the screw being there. I'll take the screw out, and then we can show the visualization on the projection of when things are missing when you're in the build process. And now I'm going to pick the screw. The system can see that there is or isn't the presence of the screw. As you can see, it's highlighting to me that the screw is not in place, so it's asking me to check that the screw is in place. Once I have positioned, it's now allowed me to move on to the next step sequence. So hopefully this has given you a bit of an overview about the Arkite incorporated with the infrared vision technology. Hopefully what you've seen as well is that it's really user-friendly, it's easy to adapt into your current network and infrastructure with the incorporation of linking with different ecosystems. You can see how easy it is to teach the system to recognize different parts of presence or orientation so that you have a full quality product from start to finish, from preventing the operator from being able to move forward in the step sequences from the validate by having the guided instructions in front of them, and then also incorporating with the vision technology for the quality product control as well.